Hello guys, good day everyone.
We are the group 7.
Our topic for today is Radix Sorting. The reporters is Adrada, Aukasa, and Urong. So guys, what is Radix Sorting? Radix Sort is a non-comparative sorting algorithm. It avoids comparison by creating and distributing elements into the buckets according to their radix. Suppose we have an array of 8 elements. First, we will sort the elements based on the value of the unit place. Then, we will sort the elements based on the value of the tenth place. And this process goes until the last significant place. So guys, this is the example of an Radix sort. Now, we must consider this input as an array. The 170, the 45, the 75, 90, 802, 24, 2, and 66. First, we must consider the one place. As you can see on the screen, there is an underline on the ones place. This is the one place, this is the 10, this is the 100 place. The ones place of the 170 is 0, at the 45 is 5, at the 75 is 5, the 90 is 0, the 802 is 2, at 24 is 4, at 2 is 2, at the one place of the 66 is 6. Now, as you can see on the screen, the numbers are arranged based on the one place. And observe the 170 has become first before the 90. This is because it appeared original list before in the original list. So as you can see here, guys, the 170 is 0, the next is 90, and the next is 802, and the 2, the next is 24, 45, 75, and the last one is 6. Now let's move on. To the 10th place, as you can see, the underline is on the 10th place. Here at the 170 in 7, at 90 is 9, at the 202 is 0, at 2 is 0, at 24 is 2, at 45 is 4, at 75 is 7, and to the 66 is 6. After we find the 10th place, this is the result of the 10th place. As you can see on the screen, now that the 802 become first. It's because of the 10th place of 802 is 0. The next is 2, 24, 45, 66, 170, 75, and 90. So now, after we find the 10th place, now let's consider the 100th place. The 100th place of 802 is 8, at 2 is 0, at 24 is 0, 45 is 0, 66 is 0, at 170 is 1, and 75 is 0, at 90 is 0. Now, we will arrange it now. So this is 0, we must put it here, and 24 here, the 45 here, the 66 here, and the 75, because it is 0 before 1. So we must put it here at the 75, then 90, then 170, and the last is 802. Now, the array is sorted. That's all for the example of sorted. Now, let's move to the complicity. Mr. Aukasa?
Complicity. Radix sort takes big O L times n plus k, big O L times n plus k times, and big O L plus k, big O N plus k space, where double N is the number of items to sort. L is the number of digits in each item, and double K is the number of values each digit can have. This time complicity comes from the fact that we're calling counting sort one time for each of the L digits in the input number, and counting sort has a time complexity of big O n plus k, big O n plus k. This complex complexity also comes from counting sort, which requires big O n plus k, big O n plus k space to hold the count, indices, and output arrays. Many implementations, including ours, we assume that the input consists of 64-bit integers, which means that the number of digits L is a constant or is a binary number. Each digit can either be a 0 or 1, meaning that double K is also a constant. With this assumption, Radix sort becomes big O and big O and time and big O and big O and space. So the explanation of what I've read is, when performing a Radix sort, the best and worst time cases will be determined based on the kind or size of data being sorted. When sorting an extremely large set or array of integers, one example would be, because data items are primarily included into an array of views, not 10 views for an LSD Radix sort, and we map to a different index point of the same input data to be sorted. Radix sorts and other forms of distribution sorts are highly quick. The distribution of keys is the deciding element. The best case scenario for Radix sorting is when they are viewed as sequential bit patterns. This will keep the keys as short as possible while keeping them distinguishable. So this makes Radix sort big O n log n. However, comparison-based sorts will be less efficient due to the assumption that comparisons will not be constant time. So Radix sort will be inferior keys are longer than big O sub n at random. There are, there are numerous other assumptions that can be made, and most of them require rigorous examination in order to produce an accurate comparison. Radix sort is not suitable for all types of data. However, it is suitable for sorting unsigned integers on a multi-core machine such as integer. So that's all for the complexity.
So now let's go to the implementation. Now the reporter is Mr. Orong. Mr. Orong.
Now I am going to present the implementation about Radix Sort. Now this is the example code of Radix Sort Java implementation. First, type import Java, then class Radix, and after that, find a utility function to get maximum value in R. Then type static int getMax, open parenthesis, int R, comma, int n, close parenthesis. Int mx equals R, open parenthesis 0, close parenthesis. For int I equals 1, in, then I++, close parenthesis. If, open parenthesis, R, bracket I, mx, close parenthesis. Mx equals R, I, then return mx. Function do counting sort of R according to the digit represented by exp. Type static void count sort, open parenthesis, int R, comma, int n, comma, int exp, close parenthesis. Then type the output array, int output equals new int n, int I, int count equals new int bracket 10. Arrays that fill, open parenthesis, count, comma 0, close parenthesis, semicolon. The store count of occurrences in count. For, open parenthesis, I equals 0, in, semicolon, I++, close parenthesis. Count, open bracket, open parenthesis, ri, slash exp, close parenthesis, %10, close bracket, ++, then semicolon. After that, change count I so that count I now contains actual position of each digit in output. For, open parenthesis, I equals 1, semicolon, I less than 10, semicolon, I++, close parenthesis. Count, bracket I, plus equals count, bracket I minus 1, semicolon. Next, build the output array. For, open parenthesis, I equals n, 1, semicolon, I greater than equals 0, semicolon, I dash, close parenthesis. Next, copy the output array to R so that R now contains the sorted numbers according to current digit. For, open parenthesis, I equals 0, semicolon, less than n, semicolon, I++, close parenthesis. Ri equals output I. These are the main function to the sorts R of size n using Radix sort. Static void Radix sort, open parenthesis, int R, comma, int n, close parenthesis. Next, find the maximum number to know number of digits. Int m equals getMax, open parenthesis, R, comma, n, close parenthesis, semicolon. To do counting sort for every digit, note that instead of passing digit number, exp is passed. Exp is 10, where is current digit number. For open parenthesis int exp equals 1 semicolon m slash exp greater than 0 semicolon xp times equals 10 close parenthesis. Count sort open parenthesis r comma n comma exp close parenthesis semicolon. Now this is a utility function to print an array. Static void print open parenthesis int r comma int n close parenthesis. For close parenthesis int I equals 0 semicolon I less than n semicolon I plus plus close parenthesis. Then a driver code and last function cell. Now this is the code of the implementation of Radix Sort using Java. Now let's run the code. This is the finished program of the code that we executed. Thank you po.
Thank you, Mr. Orong.
And that's all.
Thank you for your time, guys.